Hey guys, and welcome back. It's been a stressful week for me, so nothing more I'd love to do than to open some mail. So let's get started. I'm going to start with one of these trash baggy ones with the crinkly paper. Don't mind this electrical tape just to try to protect my privacy. I don't know if you can see this, but it says lighting accessory here. So don't really know what's in here. Let's open it up. Ooh, these are spring clips. Let's take a closer look. So these are these blocks of 3 spring clips. You can see here, when I press this down, you can insert a wire into there, and on the other side also. So basically you can connect a wire from here to here, and it should be easy, at least easier than, screw terminals or anything that needs tools. They're fairly good sized. Let me see if I can get a size measurement there. So these blocks of 3 end up roughly 27.5 mils by 19.5 mils. I don't know if you can see that. And I got these so I can connect things, or so I can build like an interface with, let's say, 2 of these blocks on top. On one side there would be power coming from my power supply, and on the other would just be to connect up random things that I find. I find it's much easier to have stripped wires than to use screw terminals or to try to solder something on. So an example is just this, I think it's a Pico blade connector, and theoretically should be able to plug this into here. Yep, see, it holds on sturdily, so I can make quick connections like this. This is part of an overall plan I have to basically have a bunch of different interfaces for connecting the same power. That means that I can mess with a bunch of different things and I never have to worry about, what connector end is on there or whatever. But yeah, it's pretty cool. So I paid about $2.30 Canadian for 20 of these, and that comes up to, 12 cents each, something like that, 12, 13. So yeah, I think this is pretty good value, and you'll see these in upcoming videos for sure, especially as I build an interface to plug all my stuff in. What I do like about this too is that they have mounting holes here. Let's see how far spaced the mounting holes are. So you want to go about in the center of the holes. They are about 10.8 mils apart, maybe 10.5 mils apart, and the opening diameter is, I'm guessing that's like a 3 mil hole. Yeah, roughly 3 mil hole. So I have 3 mil bolts that might actually hold this down really well to whatever surface I decide to put it on. Cool. Pretty simple mailbag items. This one doesn't need too much explanation. Let's move on. Next one up here is this other garbage bag looky one with the weird crinkly plastic. And this one just says electrical equip me. So I don't really know what this one is. I can feel there's something in there, so I'm going to move it to the side. I have to say, this one smells a lot like cigarettes, so it's not uncommon for stuff from China to be really smelly, but yeah, this one, cigarettes. This looks like a kit. I'm just going to open it up a bit. There we go. Yeah, that looks like a kit. Don't see a PCB though. Well, let's take a closer look. So this looks like an LM3915 kit. I believe that's an audio level indicator, and what gave it away was these LEDs, which are flat, right? They emit out the flat front here, and I think Julian Eilert got a few of these. There's a few yellow ones and 2 red ones. There's a chip here that would be the LM3915 probably, and a socket. And the PCB is actually hiding in there. So let's see here. Yeah, LM3915. PCB looks pretty high quality. Looks like the LEDs all come off here. So I have to decide if they point out that way or out this way. But yeah, this is going to be a nice kit build, just like the audio amplifier I have built in the past, and this one could actually probably even monitor the output of that amplifier kit. Awesome. I don't think there's much to see here, but let's move on. This kit also shows you the kind of block diagram and the circuit board on how to hook this up. A lot of Chinese writing, which I can't read, but I think this will be good enough to figure it out. I can see that it uses 9 to 12 volts in, and I'm guessing the audio in, this says something about speakers or whatnot, or your jack, whatever it is. Cool. Just a small aside, the bags that these things usually come in are really flimsy, and they don't have a top to them, so once you spill the components out, you're kind of screwed. So I actually just put them into these little Ziploc bags that you can get from your dollar store, and then any labeling or whatever that they provide for you, you can just put it on top there, tape it down. You have everything all in one place, and this can all go into a box with all the rest of the kits. So just found that neat. Next up, this relatively big one here. It says sensors ×2 on here, but it's a little big to be a sensor, don't you think? So let's see here. I just want to make sure if it really is sensors, I'm not cutting into anything. Oh, there's a few things in here. Cool. So the first item here, I don't think we need to zoom in too far, because it's actually, let me open this up, actually a set of clamps for measuring small components in circuit. So this should actually be able to plug into your multimeter here and here, and then you should be able to sort of clamp down on your device. Now I can see these are bent, so I'm gonna have to try to straighten these out, but I think I have the perfect kind of use case for these things. Let's take a look. So first things first, they've got these little caps on, so I'm gonna pull caps off, and inside there, should be able to see, should be a compatible banana plug to my multimeter. That seems to go in pretty nice. Okay, now let's set this to ohms. I want to see the resistance here. So I'm just gonna, first of all, I have to say these feel really cheap. Are they giving me a resistance right off the bat? That's not right. There's a resistance somewhere in there. That's not good. Well, let's start off like this. I'm pinching them shut. These things are cheap, I'll tell you that. So about, geez, depends how much pressure I put on there. There we go. 0.1 ohms, but I have a feeling that maybe there's a resistance inside here shorting the leads. Well, not shorting, I mean 55 mega ohms is kind of negligible, so this will still be useful for me, but wow, I didn't really expect that. Okay. So what use case would this be for? Well, the simple thing is I always have kind of stuff on my bench which sometimes I need to test, and something as small as this like 3mm LED here might be a bit awkward to test out, you know, with alligator clips or whatever. So I can always put this into diode check mode and sort of give that a pinch. Now obviously I wouldn't be doing this one-handed, right? But on camera I guess it's much easier not to put my fat fingers in the way. But here we go. It's OL. Flip it around. Maybe I can even flip these around. Be better. And it lights 1.767 volts. Alright, so that's good. But this is kind of made for surface mount components, right? So here is, I don't know if you're going to even see this, but right down here, that is an 0805 LED, I believe. See if we can get it to light. No, not like that. I'm going to flip this around. Whoops. This is tiny and I'm far away. Oh, there we go, 1.9 volts. So that is a tiny green LED, which I'm able to light with this one-handed. This would be really clumsy to do with, geez, anything else pretty much. So I wanted this to test these really little components like that. So that's pretty good. I can also check service mount resistors or whatever, but man, seeing that oh, now it's OL. Yeah, I don't know. So it's a bit dicky. If you need this for precision work, don't buy it. But if you need to test these tiny little LEDs, which should give you an indication of some projects to come, that I have some of these tiny LEDs, then yeah, I'd say it's worth it for that. So how much did I pay for this clamp? Well, it was $2.30 Canadian. So pretty cheap. I think it'll be worth it for what I'm using it for, but really, if you're looking at this and you're a person that loves high quality stuff, I wouldn't even bother if I were you. For me, I think it'll be fine. Let's go on to the next ones. So the next items that were in that post bag should be familiar to you if you've ever watched Julian Eilert's videos. These are INA 219 current sensing ICs. Let me just zoom in a bit if I can. And no, it turns out this is as zoomed in as I can get with this lens. So you'll just have to use your imagination. This thing is tiny. And I'm not kidding. This thing is roughly 20.33 by 21 mils. This is absolutely tiny. They give you this little screw terminal here, and that'll solder onto there. You've got two mounting holes here and here. You've got the 4-pin headers, and this is supposed to be an I2C device. Let me just check what these pins say here. So we've got VCC ground, SCL, SDA, V in, V minus. So yeah, this is I2C, so it's 4 pins. Really, you need to give it power and ground, and then the I2C communication lines. Geez, had a brain fart there. But yeah, I've got 2 of these, and if you've watched Julian Eilert's project, this is exactly the project I want to do. He's done a really good job, and I think more people should be making their own little ones of these. These are a little bit pricey. I did get the more expensive version with the purple PCB. They make cheaper ones if you want, but this one was $2.20 or so Canadian each, so I mean, I'm not breaking the bank. And I want the precision and the project that Julian Eilert did pretty much exactly. So if you want to see a beginner's perspective on making that kind of project, you can follow along on this channel. Alright, what's next? So last but not least is this white package, and I think there's multiple items in here, so I don't really know where to cut it, but let me try here. Okay, these are rotary encoders. Let's take a closer look. So if you're an Arduino beginner, this might seem really scary to you, because this is just like a potentiometer, but it doesn't stop. You can turn this all the way, and I'm not sure if you can hear that, but there's clicks between each spot. So it's like a potentiometer, but it doesn't have a resistance inside. It turns kind of forever. You've got 2 pins here and 3 pins here, and there's even an additional, I don't know if you can hear this, there's a clicky switch included into this. So here I've got 20 with their mounting hardware to get a little bit of a washer and a nut. The nut will thread onto here, then you need to get a handle for this. But yeah, these are rotary encoders, so they're like, I don't know, digital potentiometers maybe, but not quite, because they don't have a resistance. They have a signal inside which an Arduino can interpret and know which direction you're turning this and how many times you've turned it or how many steps you've clicked over. Let me see if I can set something up so I can demonstrate kind of what this does. So after a lot of messing around to try to figure out how to show you the inner workings of this, I came up with this. So I have LED here, and a different color LED there. I know it's red and it's tiny compared to this one and probably going to be swamped out, but hear me out here, okay? So first of all, this is the side with the 3 pins. I'll just get a pointing device. So that's 1, 2, and 3. This is the side with the 2 pins, 1 and 2. So this is just basically 5 volts coming in here on this rail here. This resistor, 100 ohm, I'm pretty sure. Let's see. No, 150. There's a green one. There's a green band in there. Okay, so comes in here, this pin, and then out of this pin is this LED, positive side here, negative side of the negative rail. And if I push this, you can see that LED lights up. Nothing happens on the other side. On the other side, I have this 150 ohm resistor going into this pin here, the topmost. The middle pin is connected to the positive side of this LED into the ground here, and the bottom pin is connected to this red LED and to the ground. Positive side of the red LED into the ground. Now, watch this. I'll hold this down because this switch isn't 100% breadboard compatible. The pins are very weak, and it has 2 like mechanical holding pins here and here, and they just sit into this rail here, but it's not quite a good fit. So I'm going to try to hold this, or maybe I'll hold it with this hand. I'm just going to rotate it. You see those LEDs flashing there? Okay, so it's not clear what's happening here, but let me just go slowly. I'll go even slower. Do you see that? The red comes on, white comes on, red turns off, white turns off. See that? I'm going to do it once more. Red comes on, white comes on, red turns off, white comes off. Let me try one more time. I want to get this as smoothly as possible. Okay. Oops, I can't grab the little flat there. But here he goes. Red comes on, white comes on. I'm going to go back a bit. Red's on. Oh, I think what's happening is the white is taking all the voltage, because this is just running on 5 volts. Maybe if these LEDs were matched here, you know what? I'm going to take this out. Take this LED. I'm going to try it like that. Just trying to give you kind of an idea what's happening here. Okay? One more time. I'm going to point this one up towards the camera a little bit better. Oh, there. You see now. See the transition time? So it looks like it goes flash from here to here, and then it flashes from here to here if you go the other direction. It's very hard to get it right on the cusp there. 1, 2, off. 1, 2, off. The detent is fighting me here. Let's see if I can point them opposite so they don't flash each other. So basically what's happening in here is there's a square pulse where one is supposed to go high, and then when it goes low, you can check the state of the other pulse, the other square wave, and depending when this pulse goes low, depending on what the other pulse is doing, you can determine the direction. And then after you know the direction, you can count the pulses to get an actual displacement value. It's really cool how these things work. They're a bit complicated, but not so much that we can't figure it out. If I can figure it out, you guys can figure it out. I'm sure of it. Just reviewing the video here, and if you look, if I turn this way, this one is on, but not the other one. then the other one's on, then they both turn off simultaneously. So it's like one then the other. Okay, this is turning anti-clockwise, counterclockwise. We go slowly, 1, 2, off. If I go the other way, they seem to come on at the same time and then turn off in different sequences. I wonder if mine is any different, but I'll try one more, and if it's the same result, then we're going to have to deal with this in a separate video. And here is the old one, and that's the new one. See, you get that 1, 2 in the counterclockwise direction. 1, 2, off, but on the other way, both on, then one off at a time. So we're going to have to figure out why this one is different than the ones I've seen online, and we're still going to use them. These were actually fairly expensive. These were $9 for 20, so that's about 45-ish cents each, also in Canadian. No matter what, we're going to use these. Whether or not it's going to be more challenging, well, that's a different story. And these items are today's mailbag. Thanks for watching.